web work 5. The first major concept we were looking for was that the rate of change is equal to the slope of a line. And the second thing we were looking for is that we wanted some more practice with algebraic expansions. Because even though they're not always important, there are times where they are very important. And both of these connected to what we've been doing most recently in class, which is working with power functions and working with the derivatives of power functions. So at this point, I'm going to tell you some rules that we have that are about finding the derivative. And these are purely symbolic rules. These are like what's sometimes called plug and chug, which I hate that term. Is there another way you can say it that's not plug and chug that's better? It's like pattern recognition. You recognize the pattern, you match the pattern. I call it pattern matching. So the first rule is called power rule. I like to call it patterns, not rules, but I recognize most people call them rules. So if f of x is x to the b is a number, then f prime of x is equal to b times x to the b minus 1. That's a rule that was on our handout previously. We did a little bit of practice with it last time. Another rule that we saw previously that's really important is about constant functions. So if you have a constant function, which is a function that only takes on the same value all the time. So if g of x is equal to c, where c is a number, then g prime of x is always equal to 0. And that one we actually had some justification for, because if we have a constant function, that is a flat horizontal line. So the slope is 0. Now here's where it gets tricky, because I'm about to tell you a new rule. And at first it looks like the two rules might contradict each other, and you have to be really, really careful about how to apply them. So if you zoned out and you knew everything I said during the first 30 minutes of class, would you be willing to come back now? Because this is new stuff. It's literally just a constant value. The constant multiple rule is I might have some function that is equal to a constant times another function. Do y'all see the difference? One of them is just a single number. The other one is a number times something else. In that case, what you do is you leave the constant alone and you just take the derivative of whatever the function that you're multiplying by is. And we'll do some examples to try to clarify this. And the final rule is what's called the sum. It also works for differences. So some people call it the sum difference rule. I just call it the sum rule, which says that if you have a function that is the sum of two other functions, then you take the derivative just by taking the derivative of what you're adding. So this one actually is easy to say in words. It says the derivative of the sum is the sum of the derivatives. Now we have 4 rules. And if you look up any resource you have on calculus, if you just Google calculus 1 derivative rules, you'll see these 4 rules in some form. There's really nothing to say about the rules because they're just rules, like they're just patterns. There's not much to explain. I'm just literally throwing symbols at you. But are there any questions about what the rules say?